Thank you. My name is Jeff Matayoshi, and the title of this talk is Studying Retrieval Practice in an Intelligent Tutoring System. This is joint work with my colleagues, Hasan Uzun and Cosyn. And unfortunately, they weren't able to make it today. So assuming I haven't put everyone to sleep by the end, I'm going to try and leave a couple minutes for any possible questions. I guess we'll have to do it that way. Okay, so here's a brief outline of what we'll be going over. We'll start with just an introduction of the problem and a little bit of background on the specific ITS we're looking at. We'll then go over just some exploratory analysis, some high-level results from our data, and then we'll go into a slightly more direct comparison on two types of retrieval practice that we see in this system. One we're going to call assessment retrieval, and the other we're calling learning retrieval. Okay, so retrieval practice. Well, retrieval practice is a procedure for improving the long-term retention of knowledge. And the idea behind it is that if you're forced to actively recall information that you've learned, this helps with the long-term retention of that information. And the benefits have been confirmed in many studies. These are mainly laboratory experiments, and they typically involve some sort of memorization of words or facts. So our goal here is to build on these results, and we're going to try and look at the benefits in an actual implementation in an intelligent tutoring system. So in a messy real world type of environment, we're going to try and see what we can observe about retrieval practice. So the background, the ITS that we're going to be looking at is called ALEKS. This stands for Assessment and Learning and Knowledge Spaces. And ALEKS is an online adaptive learning and assessment system. We won't need to know too much about it, just a few specific details before we get into the actual results. So an ALEKS topic or item is a discrete unit of academic course. And for our purposes, we're mainly going to be looking at math and chemistry. And we're going to look at basically retention and retrieval practice with respect to these individual topics. And each topic is composed of many example problems of equal difficulty. So there's a lot of gone into these examples to make sure they're similar, but not exactly the same. So when we're talking about retrieval and we're going to look at how the information is retained later on, they won't be exactly the same problem. So that's important. It's not simply memorization we're going to be looking at. Something a little bit beyond actual more understanding of the problem. And another important topic or important characteristic of these topics is that of prerequisite post-requisite relationship. So we're going to say topic X is a prerequisite for Y if X must be learned before Y. So this just means that X contains some sort of core knowledge or skills that you need to learn before topic Y. And so in this case, topic Y is then said to be a post-requisite of X. Okay, so very quickly, here's just a screenshot of an example topic. There's the equation the student has to solve, the input box, and the title of this one is Introduction to Solving an Equation with Parentheses. And just as another example, a post-requisite might go a little bit further, and this equation here might be a little bit more complicated. Maybe there's a couple appearances of the variable or slightly different algebra required. But that's just one example of a topic in the ITS. Okay, so something else important that we'll need to just give a brief sketch of is how a student works through this system. So the student starts with what's called an initial assessment, and this is a broad, high-level assessment that just tries to identify what the student knows at the beginning of the course. And then from there, they start working on the topics, learning them in what's called the learning mode. And eventually, after they learn a certain amount, they go and take a progress assessment. And this progress assessment is going to be important because that's going to be our mechanism for one of our retrieval practice examples. And what happens is the progress assessment and what we're going to call the regular assessment questions, the student, or the regular assessment problems, we'll call them, the student is going to be asked something that they've learned recently. So they've learned it over here in the learning mode. And then they're going to be asked it again in this assessment. And this is one form of retrieval practice. This is what we're going to call assessment retrieval. Now, I'll say a couple more words in the next slide. But this is an important mechanism. They go learn, and then they get assessed on it, and then this kind of cycle continues. The progress assessment also going to be important for us because in the progress assessment, there's one other type of question which we'll call an extra problem. And this is going to be, it's a randomly chosen extra problem. So it's chosen separate from anything that's going on with the actual assessment. And it's really used mainly for validation and to kind of evaluate the workings of the ALEKS system. But for our purposes, we're going to use it here to evaluate retention for students. So it's going to be an unbiased estimator of how students are retaining knowledge. And we can ask it after the retrieval practice occurs, and we can measure, based on how often they answer correctly, how well they're retaining the knowledge. Okay, so this is so many studies of retrieval practice use the following three-step setup. So what we're going to have is some initial study of the material, and that's going to be the learning of the topic in the learning mode. Then there's going to be our retrieval practice, and then in step 3 is going to be our test of retention. And so for our purposes, we're going to look at the performance on that extra problem as a test of retention. And that's how we're going to evaluate these different methods of retrieval practice. Okay. So here is our first example, which we're calling assessment retrieval. So the idea here is the student starts by learning a topic right here in the learning mode, and then they go on and they get it as a regular assessment problem, and that's going to act as the retrieval practice. And then later on, they're going to get this extra problem, this unbiased estimate of the retention, and we're going to look at how well they perform an extra problem, whether they answer it correctly or not. So we're going to compare this to what we're going to call learning retrieval. And in learning retrieval, you start the same way. Something's learned in the learning mode. But then next, instead of being assessed on the problem, they're going to go on and learn a single post-requisite of the topic. So we're replacing this assessment portion with this learning of a more advanced material that builds on the actual topic. And then we're going to test the retention again with the extra problem. So the assessment retrieval is analogous to what you'll see in the literature on retrieval practice, the laboratory experiments. That's pretty close to what's happening in those works. And the learning retrieval is a little bit different in that we're not really specifically assessing, but we're going to ask the student's going to learn some related material, and we're going to see how that helps with the retention. Okay, so we'll first look at some plots to kind of get a sense for what's going on with the retrieval practice. So this is all observational, and our starting data set consists of the actions of roughly 4 million students working within the ITS. And we're really going to leverage the at-scale component of the ITS to do this, because we need to, there's very specific criteria that we're looking at for these retrieval examples, so it's not going to happen that often. And by using all these students, we can extract the specific examples that fit our definitions and kind of control for some of these things. So what we're going to end up with, we're going to have about 850,000 examples of assessment retrieval and about 300,000 of learning retrieval. All right. And to evaluate them or to kind of get a sense for what's going on, we're going to look at the forgetting curves of these examples. So let me explain what's going on here. On the x-axis, we have the time in days since the topic was first learned. And the y-axis is the correct answer rate when they get the problem on the assessment, how often they answer correctly. And the solid curve, this blue one here, that's going to be our baseline curve. And we're going to use that to compare, that's actually what happens before retrieval practice occurs. So this is actually the answer rate when they get the problem as a regular assessment problem on the progress assessment. And you can see it starts high. You know, if they learn the item on day 0 and then get assessed on it really quickly, they answer at almost 80% rate. And then it quickly falls off and stabilizes just below 0.6. So after they answer that regular assessment problem, we can look at the performance on the extra problem. And to do that, we're going to split that into 2 groups. So the dashed line, this orange one, that's going to be the examples where the assessment retrieval happens within 7 days of learning. So that they learn the item, and within 7 days, they get it on as a regular assessment problem, and then we'll test the retention later on. And the dotted green line over here, that's going to be when they get the retrieval practice 7 or more days later. So there's 2 different, you can see there's some difference in performance here. The dashed orange line, when they get the early retrieval practice, it starts off high, but then it falls down, and eventually it converges with the baseline curve. So somehow the effects there wear off after about, I don't know, 40 days or so. Whereas the later retrieval practice, it starts a little bit lower, but it's much more constant, and there's much less of a decline, and you can see it stays above the other lines for over 2 months later. So there seems to be some effect here, possibly, an association at least with that the later retrieval practice helps the retention. And this is consistent with what's in the literature on retrieval practice and educational psychology. The caveat is that timescales typically there are much shorter than what we're looking at here, but at least at a high level, it's consistent with what previous studies have shown. So that was one interesting result. And we can also look at the similar curves for the learning retrieval examples. So in this case, we don't have a baseline comparison because there's no regular assessment problem, but again, we can split up this test of retention, the extra problem. We can look at what happens when the retrieval happens within a week or more than a week. And again, there seems to be a benefit to the longer gap between learning and the retrieval practice. Again, the longer you wait, this curve stays up higher, and there seems to be an extra benefit there. Okay. Okay, so that's just kind of some high-level results that we saw and that were interesting. And so next, we're going to look in a little more detail at the two different types of retrieval practice, and we'll try to compare them a little more directly. So again, these are the forgetting curves for these two different types of retrieval. And you can see that the solid line, that's representing the retention curves for the learning retrieval examples, and then the other one's the assessment retrieval. And there's a gap. It's solid, or it's consistent all the way up to 70 days later. So again, just at a high level, there seems to be something going on here, some association with the different rates of retention. But one of the problems here is that there are many possible confounding variables that are not being controlled for. So there is also additionally, students may appear multiple times in the plot, so we have some correlated data going on. And I won't have time to go over the specifics and all the details of what we did, but we tried to control for basically everything we could think of. We used several methods, such as a multi-level model, and we did some randomized sampling from our data to try to really control for these issues and the confounding variables. And so the end result is a logistic regression model that estimates the correct answer or retention rate based on the type of retrieval practice. And hopefully, by controlling for these things, this model gives us a more clear estimate of the differences between the types. And these are just this plot of the model results here. So the solid lines, again, represent the learning retrieval data, and the dashed lines are the assessment retrieval. And the squiggly lines, that's the actual raw data, just plotting it. But the straight lines, those are the actual estimates from the logistic regression after controlling for all these things. And even there, it still appears that the learning retrieval is associated with higher retention. There's a gap of about 3.5 percentage points that's constant across time. So that was interesting, and I'm not exactly sure what time it started. I think it was just after 9:15. So I'll quickly finish with the discussion, but so learning retrieval seems to be associated with higher retention, and there are several possible factors that could explain this. Going back to the literature, there are things that seem consistent with the literature. So for example, assessment retrieval consists of a single problem, and you don't get any immediate feedback. A student answers and then they move on. It's really an assessment type of environment. But learning retrieval, it requires the solving of several problems. That's known as repeated practice, which is known to help retention. It does give immediate feedback, which again is something else that's been demonstrated to help retention. And it also builds on the original topic with more advanced material. And there's this idea of desirable difficulties, that if you experience some difficulty when learning, it helps with your retention also. So in hindsight, going back to literature, while this study is observational, and it's definitely possible we've left out some confounders, at least the results are consistent with what's been shown in previous laboratory experiments. Okay, I think I'll just stop there in case there are any questions. And
fantastic, thank you, Jeff. Lots of questions in the chat.
Okay.
We might have time for one question. You want to pick one out from the last three, maybe?
Okay. Yes. Okay. I guess. Okay. So there's one about the learning retrieval. Test the original topic with a problem that relies on it as a prerequisite. Yes, so in learning retrieval, basically, instead of assessing the student on the same topic, the student has gone on and learned a post-requisite topic. So it's very related, and it builds on the original material. And that learning of the post-requisite is what we're calling the retrieval here, the learning retrieval. So it's somehow, it seems that with all these extra things going on, that building on that knowledge does seem to have a nice retrieval practice effect, or a boost to retention.
Perfect. Well, that's all we have time for, unfortunately, but please feel free to keep answering the many questions in the chat. There was a lot of engagement. Thank you for sharing this work with us.
Thank you.